order of the terms of a polynomial. So I'm going to write in a general polynomial. That would be something like y equals, let's make it ax to the third plus bx to the second plus cx plus d. Now you notice I put in 4 constants, and Desmos allows you to make them a slider. And I'm going to choose to make all of them sliders. What that means is I can now, it's picking A, B, C, and D just as default 1, but I can change A by just sliding this to 0. So if I slide it to 0, then I do not have a cubic anymore. I just have a quadratic, and it looks like a parabola. And if I slide B around, you can see what happens to the parabola. Notice there's a fixed point, and that is at 1. Well, that's what it's chosen for D. Now I got B at 0. Let's change it back to 1-ish. There's 1. And of course, if I slide D, all it does is raise or lower the parabola. So let's put it back at 1. Now the thing I want you to really notice that even though that stays in the same place, the cx, the linear term, controls the slope right at that y-intercept. Right now, c is 1, which if these were all 0, it would be a line, and c would be the slope. And so the slope is controlled by this. If I make it 0 slope, it looks like it's slope of 0 at 1. And if I make it -1 or -2, now it looks like it has a slope of -2 right there. Going down 2 for 1, 2 for 1. And whatever I make this be, that's the whatever I make C in this case be, that controls the slope. The more positive I make it, the steeper it gets in positive slope, and of course negative slope. And so you can see all the C is doing is controlling the slope of the curve at the y-intercept. The D controls the y-intercept. The C controls the initial slope at the y-intercept. The B controls whether the parabola is wide or narrow, and if it's negative, up, down, upside down. And a larger looking number, but really it's smaller because it's negative, negative 6.5, makes it pretty skinny going down, and as I get closer to 0, it gets wider and wider and flips over to positive side. So that's controlling the behavior of this graph after you get away from the y-intercept and the slope that's controlled by C. So if I make B be something like 1 or 2, I'll make it be 2, it's trying to make a parabola like this. Now let's put A back in off of 0. Now if A is positive, it tries to make this look like a cubic going up and down and up. And if A is negative, it tries to make it go the other way. But you notice a little ways, it's still got a slope of, let's see here, we got 0.7, still got a 0.7 slope near the y-intercept. It looks like a parabola as you move away, But as you get far enough away, it turns into a cubic looking graph. And with a -1 in front, the left side goes up and the right side goes down. If it's positive, the left side goes down and the right side goes up. The more powerful it is, the bigger number we multiply the cube by, the less that parabola has control. Now I can make the parabola stronger, and you can see the parabola forming around the y-intercept, but it's still a cubic. The cubic controls there. So the further you move over in the positive x direction, or the further you move in the x direction, the shape is going to be determined by the highest power term, and we call that the degree. So this happens to be a degree 3, and it will be a cubic looking graph. This has a parabola in it, and the parabola is right side up. We can turn the parabola upside down. See the parabola in here that's upside down, but it quickly goes back to the cubic shape. And we have a slope of 0.7 at the x-intercept, but you can see how I can change it to a negative slope at the x-intercept or positive x slope. And we can move the thing, of course, up or down. Okay, now let's add to this a fourth degree term. So let's call that ex to the fourth plus. So now I need to make a slider for e. It's using e is also a special number, so I'm going to call it k. So now it says, you want a slider for k? And I say yes. Well, kx to the fourth. The fourth is a curve that goes up on both sides if it's positive. It goes down on both sides if it's negative. Pick one right there. So now it's coming from the negative, coming up, then goes down, then goes up, and goes down. Notice this is now degree 4. The highest power is 4, and a degree 4 can have 1 turn, 2 turns, and 3 turns. If k was 0 and we're back to a cubic, this is a cubic, it has degree 3, because this is now k is 0, so this term's gone, and it has 2 terms. And if I make a go to 0, then the degree is 2. It's a parabola. These 2 terms are gone because they got 0 for the coefficients, and it has 1 term. So if the degree is 2, has 1 term. If the degree is 3, has 2 terms. 2 turns. There we go. See the 2 terms. And if the degree is 4, it can have 3 turns. 1 there, 1 there, and 1 there. This one's going up on both sides. If it was negative, it goes down on both sides, and you kind of miss some of the features of it when you get that big, but yeah. Positive, negative. Let's see if we can get it so we can see it. Nope, it's not showing. Okay. Anyway, that's the idea of the power of the terms. Close to the y-axis, close to when x is 0, D is the controller. C controls the slope. The linear term controls the slope. The quadratic term makes it shape into a parabola near the 0. The cubic says, okay, a little further out, it's going to look like a cubic. But the further you go out, the highest degree term controls the ultimate shape. That's the idea between the power of the terms.